All right, so the last phenomenon for the moon that we're going to talk about are eclipses. And they're sort of fun events that occur that have, in history, had some mythological significance. And when you see the pictures, we'll talk a little bit about why that might be. But they're fun events that offer some really beautiful images of the sky, and they are sort of a cosmic coincidence that they occur at all. And so we'll get into the details of what types of eclipses there are and when and where they might occur. So let's start out with the lunar eclipse. Now, the first thing you're going to want to do is distinguish between lunar eclipses and solar eclipses. And so a lunar eclipse is when the moon goes through the Earth's shadow. So when we're looking at a lunar eclipse, what we're looking at is the moon, or what we're primarily seeing is the image of the moon. And the picture here shows a sequence of events during a full lunar eclipse. So it occurs during a full moon. The moon starts to enter the Earth's shadow. And a really interesting thing happens when it becomes completely immersed in the shadow. So you notice it right here, the moon is still looking pretty gray. And you might think, well, whoever took these pictures, whoever made this, probably just used false color and made the moon appear this way. But that's not actually true. This is a real phenomenon that once the moon becomes completely immersed in the shadow, it starts to redden. And when it's completely in the darkness of the shadow, and the center of that dark shadow, it turns this sort of orangey red color. And if you've ever been able to observe a lunar eclipse on a nice clear night, you would see this. Now, the reason for this, I can explain a little bit now, and then when we talk more about light in the coming weeks, it will hopefully make even more sense. But it's essentially red for the same reason that a sunset is red. And to explain this briefly, sunlight contains all the colors. So from red to blue, all the colors are in the sunlight. But the atmosphere affects what happens to that light. And the red light doesn't scatter as much by the atmosphere, by the Earth's atmosphere. The blue light, however, scatters pretty far. So when the sun is relatively high in the sky, the blue light scatters to the sides, and that's why the sky looks blue. But when it gets lower on the horizon, the blue light has scattered off into space. It's not scattered out into the sky anymore. Now it's scattered into space. And it's mainly just the red light that we get to see. And so the sky reddens as the sun gets low on the horizon. Well, what happens during an eclipse is that the sunlight is mostly blocked by the Earth, but some of it passes through the atmosphere and bends onto the surface of the moon. But the only light that can do that, that will pass through the atmosphere without getting scattered away, is the reddish colored light. And so when the moon is completely in the shadow, or what we think of as completely in the shadow, there's still a little bit of sunlight getting through, but it's only the red light that makes its way there. And so it appears red. So what's happening? I mentioned that this occurs during the full moon phase. So in space, this is essentially the situation we have. Sun, Earth, the moon is passing into the Earth's shadow. Now that shadow is broken down into regions. There's the umbra, where we have the darkest part of the shadow, and then the penumbra, which is out here. So we divide it into regions based on their darkness of the shadow. So if the moon happens to pass through the penumbra, we get an eclipse, but not a total eclipse. It's a partial eclipse. There's still some sunlight. It'll become darker, but you'll still see the moon, and you won't get that big reddening effect at the total eclipse. But when the moon passes through the umbra, that's where you can get the biggest effect. Now, because the moon's distance from us is not perfect circle. Sometimes it passes through the umbra, sometimes it passes through the penumbra. And so we get slightly different lunar eclipses each time there's a lunar eclipse. You might ask, well, why don't we get lunar eclipses every single month? The moon is going around every month, so it goes through a full moon phase. Why don't we get one every full moon phase? Well, you could ask that, and you could also ask why we get them at all. Because it's a pretty big coincidence that the Earth's shadow would be just the right size to completely cover the moon at the distance that the moon is orbiting. And that's sort of a geometric coincidence that the way things are aligned, the moon can completely block the sun, as we'll see in a solar eclipse, and the Earth can completely block the moon for a period of time. It takes a couple hours for the moon to go through the shadow. So when you go out to view an eclipse, it's about a couple hours where it's entering the shadow and then again eventually exiting the shadow. But it's sort of an accident that we ever get this at all. But then you can say, well, if we get it at all, why don't we get it every month? And that's because the orbit of the moon is tilted at about 5 degrees from the ecliptic plane. So remember in the orbits video, I talked about how the planets are all slightly angled relative to the ecliptic plane. And the ecliptic plane is the plane of the Earth and Moon orbit. And so the moon's orbit is not exactly the same. It's sort of tilted. So in this picture, maybe this blue line should be tilted at 5 degrees. So there's really only occasional alignment of the sun, earth, and moon. Because sometimes when the moon is at its full phase, it's down lower than Earth's shadow. Sometimes it's above Earth's shadow because its plane is tilted. It only occasionally occurs that it goes through its full moon phase when it's in Earth's shadow. Now at the new moon phase, we get a different type of eclipse, a solar eclipse, when the moon is blocking the Earth. And it's a very different sort of event. So I mean, it's the same basic concept that something is in something else's shadow, but it's a very different sort of event when the moon blocks the sun. Now on the top, we see a picture of the moon in front of the sun. And it's kind of amazing, it's always been amazing to me, that the moon is just the right size. And we talked about in one of the previous videos that the moon is a larger moon than normal. Well, the fact that it is a larger moon than normal allows it to be a perfect fit over the sun. And so we can get these solar eclipses when the moon passes in front. And during that solar eclipse, we get to see the crown of the sun, the solar corona, which we'll talk about when we get to the unit on the sun. It's the only time we can see the solar corona is during a solar eclipse. And it's a different sort of event because you can look at the moon no problem. During a lunar eclipse, you can look up at the sky, you can observe the whole thing and take pictures. But for a solar eclipse, you can't look at the sun. And you don't see anything approaching the sun. The sunlight is so bright that you don't see the moon approaching the sun. You only see it once it starts, once the eclipse starts. And you can imagine that that's a pretty dramatic thing, that you have this sun there and then all of a sudden it goes dark. Now what does a solar eclipse look like on the Earth? That's what the bottom picture is showing you. So this is the shadow of the moon cast onto the surface of the Earth. So before the eclipse starts, this is all sunlight, and then when the eclipse starts, this immediately goes dark. And so it's easy to imagine why eclipses were thought of in mythological terms, right? So during a lunar eclipse, let me go back a couple slides for a second. During a lunar eclipse, the moon turns blood red. And during a solar eclipse, the sun goes away. And so these were ominous signs to the early people. Eclipses were not particularly fun events, right? They were scary. These were scary things. Why did the moon turn blood red? Why did the sun go away? And so there was mythology built up by all sorts of different cultures around these eclipses and what they meant. But they can be pretty terrifying if you don't know what's happening. It's one of the powers of science is that when you understand something, it becomes less scary. Because if you don't understand what's happening and the sun goes away, your mind can start to run wild with ideas about why that might be. All right, so we have our total solar eclipse here, and during a total solar eclipse, the sunlight is completely blocked, and we can see, so that the main disk of the sun is completely blocked, and we just get to see the corona around the sun. But as I mentioned before, the alignment is not always that perfect. Like with a lunar eclipse, sometimes it goes through partial regions of the shadow. And a similar thing can happen with a solar eclipse. And so occasionally we don't get total solar eclipses, we get what are called annular eclipses. And that's when the moon passes in front of the sun, but it's a little bit further away from us so that it is smaller in our sky, just slightly. And so it doesn't cover the total disk of the sun, and we still get to see a ring of light. So notice in this annular eclipse image, we don't see the corona. We just see the actual disk of the sun around the moon's shadow. Well, an annulus is a ring shape. So that's where the term annular comes from. It doesn't have to do with, well, it's the same root word, but it doesn't have to do with like a yearly thing. It's not like a annual eclipse. It's not a yearly eclipse. It's referring to the shape that we see. We see this annulus shape around the moon occasionally. And so sometimes we get partial eclipses, sometimes we get annular eclipses, and sometimes we get total solar eclipses. And that just depends on the precise alignment of the moon, earth, and sun. If the moon's farther away, we're not going to be able to get a total eclipse. And if it's not angled quite right relative to the sun, we might get a partial eclipse instead of a total eclipse. And that depends on where you are on the earth also. So we'll come back to that in a minute. All right, so this is the diagram from space, so we can see the difference between a lunar eclipse and a solar eclipse. In a lunar eclipse, the moon is over here at full phase and it's in Earth's shadow. During a solar eclipse, the moon is at the new moon phase and it is casting a shadow onto the Earth. And so there's a path of the eclipse. For a lunar eclipse, anyone on this other side of the Earth can see a lunar eclipse. But for a solar eclipse, you have to be around the path where the shadow falls on the Earth. So it's different to observe a solar eclipse than a lunar eclipse. Most recently, the most recent solar eclipse we've had in New Hampshire was a few years ago, August 2017. We weren't in what they call the path of totality. So this is a map showing the path of totality for that 2017 eclipse. It went sort of through the southern part of the United States and then the Midwest and into the Pacific Northwest. So if you were in this band, that's where the shadow, dark part of the shadow fell. But at our angle, we could see only a partial eclipse. So in New Hampshire, we got a partial eclipse. And during that partial eclipse, I went outside. It was in the middle of a nice sunny day, so we got a good look at it. And the way that you view a solar eclipse is not the same as the way you view a lunar eclipse. Instead of just looking up with your eyes, you can't look at the sun. So what you do is you pass the light through a pinhole and project it onto a piece of paper. And then you can see the disk of the sun. Well, I had the idea that I could just, instead of passing it through a single hole, I could take a kitchen strainer and I put the sunlight, projected the sunlight onto a piece of paper through a kitchen strainer. And so this is the image of the sun, or many images of the sun, during that partial eclipse, and you can see it kind of looks like a crescent sun. Because at our latitude, we didn't get the total eclipse. We only got to see a little fraction of the sun eaten away by the moon. But it's sort of a fun event, right? If you were just outside at this time, and maybe you were, you wouldn't really notice anything until you projected the sunlight somewhere and you could see this happening. If you were in the path of totality, it would have been much more dramatic. So we'll finish with a link to a couple of nice information sources on eclipses. And I'll open one of them and I'll leave the other one for you to take a look at your own. The first is just how to find out more about when eclipses will occur. And that's the Time and Date site, has a nice resource for that. Okay, so let me bring it into here. So this is timeanddate.com, eclipse list. And so if you want to know like when are eclipses going to occur, they have a nice feature here for when upcoming eclipses are. So there's going to be an annular solar eclipse June 21st, so on the summer solstice. This year, that's path 1, but we're not going to get a good look at it. So that's path 1, that's this path right here. Right? So unless you've got a trip planned into Asia and Africa, you're not going to see that solar eclipse. If you're looking for when we're going to get a nice solar eclipse, have a look at path 7. So that's where your calendar reminder should be. April 8th, 2024, a total solar eclipse, and the path of totality will come right through our area. So that's the next one that we're going to get a good look at. 2024, so 4 years from now, we're going to have a nice total solar eclipse coming through the beginning of April. But this shows you lunar and solar eclipses together. So these are all solar eclipses here. I could switch this over to lunar eclipses. So when are we going to get lunar eclipses? And then we have, and notice the coverage is much greater with lunar eclipses. So penumbral means just going through the penumbra, so it won't be the total deep eclipse that gives you that nice bright red moon. But June 5th, we'll get one of those. Then, well, we won't, but part of the world will. The other half, our half will get one July 5th, and so maybe we can make an event out of that and try to observe the penumbral eclipse. Hopefully the weather cooperates. If it's cloudy, it kind of ruins things for us. But if we get a nice day, July 5th, we should all try to go out and view the penumbral lunar eclipse. And then again in November of this year. So if you look through this, you notice there's not really a pattern here, but we get 2 to 3 eclipses a year. Sometimes there's a gap, right? Look between 22 and 2025. There's nothing, but it's all dependent on the alignment, and sometimes we get lucky and get a few in a year, and sometimes there's just a gap. And the same sort of thing happens with the solar eclipses, but the solar eclipses are more specific to the area on the Earth, and so they're a little bit harder to observe. You have to be near the path of totality, whereas every time there's a lunar eclipse, half the world gets to see it. All right, so you can explore that more on your own if you're interested. I also put an article here from the Washington Post, which came out for that 2017 solar eclipse and has a lot of nice visuals that will show you more about the details of where that eclipse occurred and how eclipses work in general and when they're coming through again in the future.